Alright, welcome back. Here are your notes for section 9.6, proportional parts and parallel lines. So I've got a theorem for you. If three or more parallel lines intersect two transversals, they divide the transversals proportionally. So I've highlighted the transversals for you, and proportionally we know that the ratios will all be the same. So if line L is parallel to line M and parallel to line N, so three lines are parallel to each other, then AB over BC is equal to DE over EF. Also, AB is over, so this short part over the whole part, AC, is equal to DE over DF. And then that last one, erase that so I can draw it in there for you. BC, so the short part over the long part, AC, is equal to EF over DF. Again, those proportions are, the ratios are going to be equal to each other. All right, our first example here says to complete the proportion. So again, I've got three parallel lines cut by those two transversals, so they divide those parts proportionally. So I have MN over MP is equal to RS, so this short part over the long part. So again, because MN was used, I have to use those same, in between those same parallel lines for the second part. Okay. Down here, example A, I see that MN, I'm going to erase my lines here. So I've got, let's see, I'm not quite sure why that's not erasing, sorry about that. So anyway, MN is equal to 12, so I'm going to go ahead and mark that here. So that's equal to 12. NP is equal to 10. RS is equal to 6. We're trying to find ST. So I'm going to set up my proportions here. So I'm going to say 12 over 10 is equal to 6 over x. We should be really good at solving proportions now, those cross products. So I've got 12x is equal to 6 times 10. So 12x is equal to 60. Divide both sides by 12. I've got x is equal to 5. So that is ST. So ST equals 5. All right, let's erase some of those numbers here. MP, so this whole part, I've got it already kind of arrowed there, is equal to 20. RT, this whole part, is equal to 16. This time I'm using NP, so NP is equal to 12. We're trying to find ST. I'm going to go up ahead and set up those proportions, so I'm going to say 20 over 12, so this long part over the short part is equal to this long part, so 16 over x. Use our cross products here to solve. So I've got 20x is equal to, let me get a calculator here. Let's see, is equal to 12 times 16. So 20x is equal to 12 times 16. We've got 192. Divide both sides by 20. And I've got x is equal to, I'm going to have a decimal here, of 9.6. All right, so again, since I've got three parallel lines cut by a transversal, can set up those proportions. All right, moving on to the next example, I see here that A is parallel to B is parallel to C, so I'm going to go ahead and just mark those lines. That means the sides are proportionate, those segments that they intersect with are going to be proportionate to each other. So I am solving for x right here. Set up some proportions. So I'm going to say 12, so this part, over 18 over this part is equal to this part here, so 15 over x, using our cross products, which we're getting really good at. 15 times 18 over here. 15 times 18 is equal to 12 times x. 15 times 18 is 270 equals 12x. Second step, divide both sides by 12. I've got x is equal to, let's take that divided by 12. We got 22.5. Again, since we knew that they were parallel, we knew that those side parts, those sides of the transversals are proportionate. Next slide here. Oops, I don't want that drawing. I want to make it a little bigger for you. So I've got a figure down here, and I've got line L parallel to line M. I'm just going to highlight their letters for you. Line L, line M, and N are all parallel. Asking me to find the value of x. So x is this little part right here. So I see I've got a 5 that corresponds with that x for the transversals being cut, and then I've got 30 and 20. So I'm going to go ahead and set up my proportions. So I'm going to say 5 over 30 equals x over 20. So again, that's this part over this part is equal to that x over 20. Again, we knew they were parallel, so we know they're proportionate. So 5 times 20 is equal to 30x. 5 times 20 is 100. Second step here, divide both sides by 30. And I've got x is equal to, give you that decimal, divided by 30. I've got 3.3 repeating. Okay. Let's see here. Can I move that? That didn't do anything for me. Take this. That still didn't do anything. Trying to move it out of the way, not going to work. We'll work around it. Over here I see that my 3 lines are parallel. I've got my parallel markings here. So I know that their parts that are intersected are proportionate. Set up my proportions here. I'm going to say 5 over 8 right here is equal to 3.75 over 2x minus 4. Again, working on our cross product, so I've got 8 times 3.75, I'll put that in parentheses, is equal to 5 times the quantity 2x minus 4. So let's see, 8 times 3.75 gets us to 30. Oops, and over here I've got 5 times 2x is 10x, and then minus 20. Add 20 to both sides here. I should probably give that separated so you can see the difference here. Add 20 to both sides. So I've got 50 is equal to 10x. Final step. Divide both sides by 10. That's my dead spot in my iPad. Here we go, 10. And so I know that x is equal to 5. Checking back here, it just wanted us to find that value of x. So again, by using that proportions and cross multiplying, we are solving then for x. Next theorem says if 3 or more lines create congruent segments on a transversal, then they cut the congruent segments on every transversal. So if 3 or more parallel lines create congruent segments, so if line L is parallel to line M, which is parallel to line N, and AB is equal to BC, or congruent to BC, then I know that DE is congruent to EF. Oops, let's fix that congruent here. So if I've got congruent segments on one transversal. So let's say I'm just looking at my transversal over here, and I know that AB is congruent to BC. I also know that those parallel lines cut the other transversal into congruent parts, that DE then, DE is congruent to EF. All right, so looking at this value here, or this last example before we give you time to work on your homework, I see that this side right here is, I've got 3 parallel lines, and the transversal is cut into 3 congruent parts. So therefore I know that these other sides are also going to be equal to each other. So in order to solve for x, I'm going to say, get you my pen back. Get you my pen back. So I'm going to say, let's erase this for you. 12 is equal to 2x minus 6. Add 6 to both sides. 18 equals 2x. Divide both sides by 2. I've got 9 is equal to x. Just to plug those in to see what those sides are. So I've got 2 times 9 minus 6. So 18 minus 6, that becomes 12. And then I've got 9 plus 6. That's also going to be equal to 12. So just to double check, all 3 of those parts are equal to 12. And again, that's because I have one transversal. So this transversal over here is divided into 3 congruent parts with those parallel lines. Therefore, I know the other sides are parallel as well, or congruent as well. Sorry about that. All right, here is your assignment. You guys can go ahead and get started on that. If you have any questions, let us know.